Let's take a look at solving with square roots. So we know we can solve an equation with just square roots when we see only one thing that's being squared. So in these two examples, we just see that x plus 3 is being squared. In the following set of examples, like here, just the x is being squared. So we would solve by factoring if we had something with just an x also, if we have x squared and something with an x. But we do not have that here, so we would solve with square roots. So in the solved example, the first thing we want to do is identify what is being squared. So x plus 3 is being squared, and that's why I circled that. And then the minus 5 equals 11. Okay, so the steps to get this x plus 3 isolated, which is step 2, so isolated means this is the only thing on one side of the equal sign. I would add 5 to the other side. So to get this alone, I add 5 to both sides, and that's how I get x plus 3 squared equals 16. Then we have to take the square root. So we take the square root to undo the square. That's the opposite operation. So when I take the square root here, it cancels out this square, so I'm just left with what was in the parentheses, x plus 3. The square root of 16, this is where we have to be careful, because taking the square root of the number, it could be either positive or negative of that number, because 4 times 4 would give you 16, and negative 4 times negative 4 would also give you 16. So that's why we have to have both possibilities of it being positive or negative. So what I did here was I wrote x plus 3 equals the positive 4, and x plus 3 equals the negative 4. So I have those two sets here. So all I did was just broke this down, rewrote it twice, with the positive case and one with the negative case. And then doing that last step of solving by subtracting 3 on both sides to get these answers. To check on Desmos, you would type this expression into Desmos, equation I mean, and then you would see where those x-intercepts are to see I have negative 7 and 1 for the answer. So I'm going to do the third example here. So the first step would be isolate. Isolate what's being squared. Okay, so just the x minus 3 squared is being, x minus 3 is being squared. 2 is not part of that. So notice, please make note of that. If you have a number outside of those parentheses, this 2 is not being squared. Just the set of parentheses is. So step 2, I need to isolate. Oh, sorry, that's step 2, isolate. Step 1 is identify. My bad. All right, so now I'm going to isolate this expression. So I have 2x minus 3 squared minus 3 equals 5. So to isolate this, this is the same as if I had 2x squared minus 3 equals 5. So like instead of x squared, we have x minus 3 squared. So I would do the same steps to solve here. So first you do your adding, subtracting, so I would add 3 to the other side. And then I would divide out this 2. Okay, notice when I divide 2 here, this is 2 times this entire expression. So when I divide out 2, it just cancels out that 2 that was in front. And then 8 divided by 2 is 4, is what I end up with here. Okay, so your steps for solving, we don't do anything with this. We're leaving this alone until it's totally isolated on one side. So I first do the adding, subtracting, so this is minus 3, so I'm going to add 3 to cancel it out on this side to get 8. And then 2, if this is 2 times this expression, so I would just divide 2 on both sides to cancel it out to get 4. Okay, so step 3 is you take the square root of both sides of the equal sign. So on this left side I have x minus 3 squared, and on the right side I have 4. So when I take the square root of x minus 3 squared, that cancels out that squaring action here. So I'm just left with x minus 3. This does not change the sign here. This stays the same. for the square root of 4, just my number, this is where we have some signs. We have plus or minus 2. So step 4 is where we solve for x. Okay, so first thing I do, since it's positive or negative 2, I set this up as x minus 3 can equal positive 2 and x minus 3 can equal negative 2. The last step here would be adding 3 to both sides. Okay, so I add 3 so it cancels out on the left side and I get x alone. Okay, so this is always your goal, getting that x alone on one side. Adding 3 here would give me 5. And then to get x alone here, I add 3, and that would give me a positive 1. So when you go to check this on Desmos, you type in this, and you look at what those x-intercepts are. When we have just the x being squared, it's slightly less steps. So first thing, what is being squared? Just x is being squared. We want to isolate what's this x squared on one side, so I just want x alone on the one side. To do that, I would add 5 to both sides. So when I add 5, on the left side it cancels, so then on the right side it becomes 16. Taking the square root of both sides, this is just x squared, so when you take the square root, it cancels out the square, and I'm left with just x. Square root of 16 would be that positive or negative 4. So I'm going to do another example with number 6. So step 1 is identify what is being squared. So just this x is being squared. This 2 is not being squared. Okay, so the square is right next to the x. If this was in parentheses together being squared, then we would say the 2 is being squared. But it's not. The square is just with the x. So we need to isolate what's being squared. So I have 2x squared minus 3 equals 29. So to isolate, I would first add 3 to both sides. So I add 3 so this cancels, and I get 32. Okay, and then to get x squared alone, so we have to get this x squared alone, you cannot take the square root of this number with x. We have to divide it out and get x squared alone. I cannot repeat that enough. So x squared is equal to 16. 32 divided by 2 gives me the 16. Step 3 is we take the square root of both sides. Both sides. Okay, so the square root of x squared, that's what I had here, and the square root of 16 goes in here. So this square root cancels out my square, and I'm left with just x. Square root of 16 would be plus or minus 4. Okay, so when taking the square root of just the number, this is what we end up with. So our answer here, since we don't have any other steps for solving for x for this case, it would be x equals positive 4 and x equals negative 4. So I just broke this up into two answers showing it's positive 4 and x equals negative 4. If you left your answer like that, it would not be wrong. I'm just showing you how you still have two answers here. Okay, and then the Desmos check, you can't really put the picture in here, but you're going to check on the graph by typing this in that your two x-intercepts are at positive 4 and negative 4.